Welcome to this video on chemical properties and change. We really study matter, and when we look at the physical versus the chemical, a lot of the physical is going to be states of matter, mixtures, things that are just changing but not the chemical composition. Whereas with chemical change, we actually are going between things like compounds and elements, and we're working within these pure substances and changing them chemically so that's a new composition. Here's some examples. So we see some rust or some oxidation happening here. In this second one, we actually have two different clear liquids that are reacting and they're forming this new substance, which we call a precipitate. It's a solid. We have some metal that is in a solution and it's bubbling, which is a good indication that there's a reaction occurring. We're adding some electricity here to water and we're separating it into oxygen and hydrogen. And then of course, here's a combustion reaction. We are burning some stuff and giving off light and heat. So we have these chemical equations and they're a representation of what's going on in the reaction. They show chemical formulas and the different things that are happening there, conservation of mass or matter, transfer of energy, and then they have this specific format. And so when we have these equations, we know that we always start with our reactants. Think of this as the before. On the left-hand side, and then on the right-hand side, the new thing that we have, or the after, are going to be the products. So our reactions and energy, so energy is always involved. We have a transfer of energy. And we can have an endothermic reaction or an exothermic reaction. So with an endothermic reaction, it's going to absorb energy. And so when we have those reactants versus products, and I'm going to just use an R and a P for those. So the reactants plus energy is going to form our products in an endothermic reaction. And then in an exothermic reaction, it's going to be the opposite. So we have reactants that are going to change. So that arrow always represents change into some products plus some energy. Heat and light a lot of times are ones that we see very clearly as that energy. So there's 5 major types of chemical reactions, and we're going to learn more about these as the year goes on. But in this first one, we have 2 individual things, and they are going to form one thing, and so we call this synthesis. Some textbooks refer to it as combination reactions, but I like synthesis best. In the second one, we see water, one thing, and then we're going to split it apart into 2 different things, and that's going to be something we call decomposition. The third one here, we actually have a unique situation where this zinc is going to replace this hydrogen, and so the zinc ends up moving to be with the compound itself, and zinc gets displaced or replaced. And so this is what we call single replacement. And just whenever you have a compound in just one thing, that's going to be single replacement. If you have something like this, and this looks a little more confusing, there's a lot going on. Here we have lead and chlorine, so we're going to swap partners basically, and they form lead chloride on the other side. And then we have sodium and nitrate, and they're going to form sodium nitrate. And so this is one that we call double replacement. Okay, so I'll write that here, double replacement. So completely swapping those partners. And then the last one that we have, we see a carbon-based compound and oxygen. And oxygen is the big one. We actually see this happen up here. If oxygen is a reactant, okay? Only when it's a reactant, it has to be on the left-hand side, it's a combustion reaction. So the first one actually is not only synthesis, but it's also and combustion. Okay, so the iron would be burning essentially, or oxidizing there. And in the last one, this is the classic combustion reaction. So we have a carbon-based compound with oxygen, and so this is going to be combustion. Now, if it's a carbon-based compound, carbons, hydrogens, maybe some oxygens, nitrogens, and oxygen burning, then it's always going to form CO2 and H2O, so carbon dioxide and water. So let's take a look at these and let's see if we can predict products. This is a little more advanced. I'm going to ask you to give it a try, but we will learn how to do more of this later. So here we see that we have two individual things. The only thing we can do is combine these. So NaCl, and if you're not sure exactly how to do that, it's okay. I just want you to give these a try. In the second example, we have magnesium and oxygen, just one compound. The only thing we can do is break it apart into its elements. So we have Mg plus oxygen. Just so you know, oxygen is, if it's by itself, always has to be O2 in nature. And if you don't remember that right now, it's okay. We'll get back to that later. And the third one, we see we have copper by itself, and we have a compound. Now, the copper has to replace the metal, okay, or the thing that comes first, because they're both equivalent. So it has to replace the metal, and so we would end up with copper nitrate, CuNO3, plus silver by itself. So we would be single replacement there. Of course, here we see another carbon-based compound. So carbon-based compound and oxygen, we know it's combustion. And when it's the carbon-based compound, it's always going to be carbon dioxide, CO2 plus H2O. I'm not showing matter as being conserved here because we're not balancing equations yet. We'll get to that later. Finally, in the last one, we're going to swap those partners again. So sodium is going to form with the chlorine. So the first one in the N1 and the last one in the second one. So we have sodium chloride plus, and then we see the OH and the H. And if we put an H and an OH together, we actually get H2O. I hope that was helpful.